So now we're going to discuss the basic differentiation rules. So first, we will start by letting y be equal to f of x. And to recall, there's a couple different ways to denote the derivative of this function. So one way is y prime, another way is f prime of x, another way is simply dy over dx. And you can also even do df and dx. So in the notation that follows, we're going to use this notation here. So the first rule says if we take the derivative with respect to x, so d dx means take the derivative with respect to x of a constant function. What do we get, Will? Let's think about it. The derivative is the slope of the tangent line. So if you were going to graph a constant function, say c, it's horizontal line. So if you pick any point on this line and you draw a tangent line, you get the same line, so the derivative is the slope of this line. Well, horizontal lines have a slope of 0, therefore this derivative is 0. So the derivative of a constant is 0. It may sound silly, but let's do a simple example. Say we have f of x equals 2, and we're asked to find the derivative of the function. Well, all we do is we write f prime of x, and the answer is 0. So the derivative of a number is always 0. Very important rule. The second formula is extremely important. It's so important, it's given a name, it's called the power rule. So the power rule says if you take the derivative with respect to x of x to a power, so x to the n, what you do is you just put the n in the front. So you put the n in the front and you subtract 1 from the exponent. So write n minus 1. Okay, that's called the power rule. The power rule, let's do a simple example. To say we have the derivative with respect to x of x cubed of x cubed, this means take the derivative with respect to x and x cubed, so you put the 3 in the front, so you get 3x, then you just subtract 1. 3 minus 1 is 2. There it is. We're doing calculus, right? Let's do another one. D and dx of x to the fourth. So you put 4 in the front, you get an x. You subtract 1, so you get 3. That's the power rule. Put the number in front and subtract 1. The next rule says if we have a constant times a function of f of x, the constant can hang out. So say we have d dx of c times some function of x that we'll assume is not constant, or even if it's constant, I think it will still work. This is c times the derivatives of, even if it's constant, will work because if f is constant, its derivatives is 0. So everything makes sense because you get constant times constant, which is constant. So life is good. So very powerful formula basically says constant hang out. So here's an example. Say we have f of x equals 4x to the fifth. So we take this derivative. So f prime of x, and I'm using different notation just to show you that you could write the d dx, or so you can write f and then write f prime, whatever works. So you put the 5 in the front. The 4 just hangs out, so you do 5 times 4, so it's 20x. Let us subtract 1. 5 minus 1 is 4, so again 5 times 4 is 20, and you subtract 1 and you get 4. So we use this rule. The 4 was the c, so kind of just like stays back there and just kind of hangs out. Then we have, let's look the derivative of some trigonometric functions. Look at the derivative of some trigonometric functions. So we have the derivative of sum that's equal to cosine, sine that is equal to cosine. So just totally worth memorizing. The derivative with respect to x of cosine is equal to negative sine. A little bit harder to remember this one. The derivative with respect to x of, let's do the tangent next. It's not another common function. This one is secant squared, so you might say I'm never going to memorize that. I thought that people can learn calculus. You can learn calculus, so the derivative of tangent is secant squared, like you will know it. After lots of problems, then we have the harder one. So the derivative with respect to x of secant, that is secant tangent. And the really uncommon ones are the ones for cotangent and cosecant. So the derivative of cotangent is negative cosecant squared x, and the derivative of cosecant is negative cosecant cotangent. So there is a couple things posed here. There is a couple tricks to memorize this. If you take the derivative of anything and it starts with a c, you're gonna have a negative sign. So that's all for this topic. Thank you. So now I am going to discuss the trigonometric identities. So the first section where we're going to define an identity. So an equation in one or more variables is called an identity. If the equation is satisfied for all the possible values of the variable involved in the equation.